day, my dear students. Today, I am going to discuss with you one of the methods in solving the resultant vector. In our previous discussions, I said that there are two physical quantities in the universe, the physical universe. And these two physical quantities are the scalar quantities and the vector quantities. Scalar quantities are those physical quantities that do not require direction, just the magnitude. Like time. Our time today is what time? Then the time given has no direction because time does not need direction. Okay? Density of immaterial does not need direction. The length of a particular object, like what is the length of your ball pen? That length does not need direction. But physical quantities like force, you cannot apply a force without direction because it is an inherent characteristic of a force to have direction. Without a direction, suppose I want to box you. Box! Oh, in every act of boxing, there is that direction. Even if you are just 1 centimeter away from me and I'm going to box you and I don't have direction, I cannot hit you. I want to hit you right in front of me. How will I hit you? I must apply a force that has direction. No direction, I cannot hit a target without a direction. Force needs direction. Current, electric current needs direction. Without a direction, where does the current flow? Current is a flow of charge. Where does it flow? Where does it flow? It is flowing in a certain direction. Okay? So just relax. We will continue the discussion about vectors, but this time we are going to use a tool in determining the resultant vector. There are many tools. There are many methods in solving the resultant vector. But today, let us have one method we call the graphical method. We will be using the ruler. We will be using the protractor. And these are the things that we need to have. Of course, our writing material, ball pen, of different colors. Of course, a piece of paper. And the best is the graphing paper. But if you are just skillful enough to draw straight lines, you don't need a graphing paper. Here, I will be using the board. I will be using the board, okay, as my paper. Then instead of the ruler, I will be using the meter stick. And instead of this protractor, I will be using this one. Okay? Okay. So, let us have a review of the problem we discussed last meeting. We use the Silliman campus, the campus of Silliman University. And in that discussion, we consider a specific location that a student of Silliman University walks toward the Silliman University cafeteria. And the student started at the Science Complex building. Science Complex building over there, somewhere there, at the location which is the boundary of Nursing building and the Science Complex building. Right now, I am at the third floor of Science Complex building. The student will have to start somewhere there, over there, to walk his or her way in going to the Silliman University cafeteria. So we said that the Silliman campus, I made a drawing of the Silliman campus, and the students have vectors, and these vectors will be A and B, vector A and vector B, which is the displacement vectors. Okay, the given, okay, we have the given vector A equals 100 meters, no, 48 meters. What we consider was the distance 48 meters going toward, let me have the actual situation. If you are in Silliman campus, you started near the HE building, Home Economics building, somewhere there, over there. Then you go to the Silliman cafeteria. You decided to go along the Science Complex building. So there is a path walk for students. Okay? And the distance is 48 meters to walk from the origin toward the road along the Real Hall. There is that road there. Okay? You use that road in going to Silliman University Church. You will use also the same road in going to the cafeteria or to the university business office. So you walk directed south. Okay? And then, from there, you are going to have another displacement vector 100 meters east. To solve that problem, because we would like to know what is the resultant vector C. What is the resultant vector C? Now, there are many ways. You either use the component method, you use the analytical method, but today we will be using the graphical method. Okay. So, 48 meters going south. Okay. 48 meters going south. That means we use the geographical coordinate. Okay? The geographical coordinate system. Okay? The geographical coordinate system, which is this one. This one is east, this one is west, this one is south, this one is north. Okay? And so, we first represent the two vectors with an arrow. An arrow. Where an arrow has a head and has a tail. Okay? After having that, the arrow, we have to establish a scale where the scale is used to represent the magnitude of the displacement vector by the length of the arrow. The bigger the magnitude, the longer the length of that arrow. So we have the magnitude, 48 meters, 100 meters. Magnitude will be indicated by the direction of the arrowhead. Okay. So east, south, for the direction, I'm going to have a scale. I need to have a scale that for every 1 meter, that is equal to 1 centimeters. That's my scale. I cannot use 48 meters as 48 meters because I need 48 meter sticks because this is 1 meter and there are 48 meters. So I need 48 meter sticks. For every meter stick, 1 meter. This one, 100 meter stick. So I need to establish a scale that for every 1 meter, 1 centimeter. Therefore, these 48 meters applying the scale, this one is equal to 48 centimeters south. This 100 meters is just equal to 100 centimeters east. So 1:1. Okay. So here, I will have the first vector. Vector A. 48 centimeters. So 48 centimeters, I will have to have 48 centimeters. So 48 centimeters, 48, 48, so 10, 20, 30, 40, 48, 48, so I will start here, 48, 48, 48. Okay, here. I will start here. 48, 48. There you are. This is the arrowhead. And of course, this is the tail. So this is vector A. This is vector A. Equals 48 centimeters south. Then, the next vector is east. So, east going there. Wait. I will have this one. I need east. So, I have to transfer this one so that this can be accommodated. So, I will start here. 48. South. Okay, I'll just start here. South. 48. 48 centimeters. Okay, 48 centimeters. 10, 20, 30, 40. 48 is somewhere here. Okay, 48. Ready, get set, go. 48. There you are. So this is the arrowhead. And this is the origin or the tail. Okay, this is vector, yes, okay, vector A. This one is vector A. That's vector A, represented by an arrow. And being a vector, it has magnitude and direction. The magnitude is 48 meters, drawn to scale 48 centimeters. So, the magnitude now is represented by the length of the arrow. And this length of the arrow from here to here represents the magnitude. The direction south, going south. Okay, next vector, vector B. 100 meters, drawn to scale 100 centimeters. Direction east. So, toward the east. So, I'm going to have that toward the east 100 centimeters. Okay. So, 100 centimeters. I will see to it that the distance here from the edge is up to here. Wait here. I'm going to have here. This is, because this is not a graphing paper, so I have to be extra careful. So I will have here, okay, I have to be here, this one, so that I can have a straight line there. This point, then 2 points determine a line. 2 points. This point, the end point of the arrowhead, this point determines a line. A straight line. Okay. And the length is 100 centimeters. The length is 100 centimeters. 100 centimeters. So therefore, I need to have 100 centimeters. Okay. Okay. 100 centimeters. Okay. 100. Oh. No, it's not. Oh, wait. Not so a straight line. If this is a graphing board, better. 100 centimeters. 100 centimeters. 100 centimeters. Oh. Okay. So, this is the arrowhead. There you are. This one is displacement vector B. This is the head. You have here the tail. So you have the tail here. For vector B, the tail, the head of vector B. For vector A, the tail, this is the tail, This one is the head of vector A. So this is it. Now, to determine the resultant vector, that resultant vector is another arrow. Another arrow will be drawn. Where are we going to draw the third arrow? First arrow, second arrow, arrow B, arrow A, arrow B, vector A, vector B. The third arrow, vector C, the resultant vector is drawn from the tail of the first vector. The first vector is vector A. From the tail of the first vector to the head of the last. So, from the tail to the head of the last. Oh, I need a longer arrow, so I need to have another like this. So, I need two. Oh, I need two. Okay. I need two. There. Okay, from the tail to the head. There you are. Okay. A little bit careful in drawing. A little bit careful. There you are. This is now the resultant vector. I have the third arrow as the resultant vector. I'm going to have another color. I will use color red. Color red to indicate that this arrow is the arrow of vector C. Another color red. This one is vector C. Okay. So you have this one. There you are. This is vector C. Our question is, what is vector C? To solve for vector C, we apply the graphical method with the use of the ruler for your paper, meter stick for the board. Okay, so we make a scale to reduce the size because we cannot afford to have vector A 48 meters. We need to have a scale. And we choose the scale 1 meter equals 1 centimeter. Therefore, for vector A, 48 meters equals 48 centimeters. 1:1 ratio. Then vector B, 100 meters becomes 100 centimeters because of the scale. And we did it. The magnitude of the vector is represented by the length of the arrow and the length in terms of centimeters. Applying the scale, 1 meter equals 1 centimeter. Magnitude. How about direction? Where the arrowhead is directed, that is the direction. So this one is directed south based on our geographical system. South. Next, east. So, going there. So, connect at the head. The tail of the second arrow is vector B. Connect at the head of the first arrow, vector A. There, this one represents vector B 100 centimeters, which is 100 meters in actual value. Applying the scale, the 100 meters becomes 100 centimeters. Find resultant vector C. The resultant vector C or any resultant vector It could be D, it could be F, where vectors can be represented by letters, is drawn. That resultant vector is drawn from the tail of the first. Vector A is the first. From the tail of the first to the head of the last. Now, what is the magnitude? The magnitude of the resultant vector C is determined by the length of the arrow. So, length of the arrow, okay ha, I hope you can see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 here. So, there is an excess of 100, and the excess here is 11 centimeters. The excess is 11 centimeters here. 11. The excess is 11. The excess is somewhere here. Excess is somewhere here. Here. 11 centimeters. The excess is 11 centimeters. So therefore, 111 centimeters. The length of the arrow vector C. 111 centimeters. So, I will write this equals 111 centimeters. Okay. Now, what is the direction? The direction, my dear students, can be determined using this geographical coordinate system. Okay? As you can see, vector C is located at the fourth quadrant. First quadrant, second quadrant, third quadrant, fourth. At the southeast quadrant or east-south quadrant. And therefore, it will have a direction, okay? It will have a direction somewhere south of east. What is the angle? The angle can be known using the protractor. You are not allowed to have computation of the angle because computation is not applicable in graphical method. What is applicable is the use of protractor, actual determination of the angle. Do not use tangent, cotangent, sine theta, cosine theta. That is a matter of computation. This is a matter of geometrical determination. Graphical method. Okay, so we use the protractor. So, very small, very small, very small. I will use very large. Okay, so now I have here, there's a hole, there is a line here. Huh? There's a line. There's a line. Straight line. Repeat this line. Repeat this line. Okay. So this line should align with the x-axis, horizontal. Horizontal x-axis, or the east-west coordinate. Or this one is the horizontal axis. Remember, this is x, this is negative x, this is y, this is negative y. So you are going to apply that one after the other. You can apply that simultaneously. So we are applying here simultaneously that our east is the positive x along the positive x-axis. Our north is along the positive y-axis. Our south is along the negative y-axis. And our west is along the negative x-axis. So we have at the fourth quadrant, as I said, this one should align. So I'm going to extend the east-west line, okay, or the horizontal line. I'm going to have this there extended so that this line, as I said, this line should align with the horizontal axis, the east-west axis or coordinates, east-west, or the x-axis, the horizontal axis. Okay. Just like your protractor, there is a line. Protractor, there's a line there. Okay? There's a line parallel to this one. There's a line parallel to this. Okay. So here, I'm going to put, there's at the center line there. To determine the angle, 90 degrees should be aligned with this one, vector A, or along the y-axis. This is along the y-axis. Align. There. Okay. And you're going to get the angle. Okay. And the angle here is 64. Okay, let us have 64. At 10, 20. I will repeat that. 90 is the reference 0. 90, 80, that's 10. 80 to 70, that's 20. 70 to 60, 30. 60 to 50, 40. 50 to 40 is 50. 40 to 30 is 60. And this one is 64. 64. So therefore, okay? Therefore, wait, this is 64. Okay? This one is 64. Okay? And if this one is 64, this is 26. So this one is 26. This one is 64. And if this one is 64, you have this one. Okay? If this one is 64, you are going to have here a line, a straight line. I hope you can follow. There. If this one is 64, this one is also 64. And if this one is 26, this one is also 26. You have that a theorem in trigonometry. The sum is 90 degrees. The sum is 90. Okay? You get it? Huh? You get it? Now, so, our vector C, therefore, there are many ways of determining. There are many ways of expressing the answer. You can use, okay, you can use 26 degrees, if it is south of west, that is 26 degrees south of west. Therefore, the angle is measured from the east axis, or from the x-axis, or from the east coordinate. So this one is our east. Of course, this is also positive x. And this one is west. And of course, this is negative x. So, the vector C is 111 centimeters, 26 degrees south of east. Okay? This is for graphical method. This is for graphical method. But in terms of the actual distance walked by the students, using our scale, 1 meter equals 1 centimeter. Therefore, the student will walk 111 meters, 26 degrees south of east. The resultant vector is always greater than any of the two vectors. Greater than A, which is 48, greater than B, which is 100. 111 is greater than 48, greater than 100. Okay, now, so, this is your one way of expressing the direction. Another way of expressing the direction, our C is equal to, another way, 64 degrees east of south. 64 degrees east of south. So, 26 degrees south of east or equal to 64 degrees east of south. Another, vector C is equal to 26 degrees clockwise. Or vector C is equal to 334 degrees counterclockwise. No need to have the direction east, north of east, or south of east, or west of south. No need if you will be using clockwise and counterclockwise. Clockwise should start from the positive x-axis. Clockwise angle should start in its measurement from the positive x-axis. Counterclockwise angle, 334, should also start from the positive x-axis. Okay, so in other words, here you will have this is north, south, east, west, or x, or this one is x, negative x, y, positive, and negative y. Clockwise and counterclockwise angles always start from the positive x-axis. So, 26 degrees starts from the positive x-axis. So, 26. This is 26. 334 counterclockwise, so against the clock, counterclockwise, in that direction. 90 plus 90 is 180, plus 90, 270. 70 plus 64, 70 plus 64, because this is 90, 180, another 90 is 270, and this one is 64. Right? This is 64. So, 270 plus 64 is 334 degrees counterclockwise. You have to remember that. Because I'm going to give you the assignment. Okay? I will give you the assignment based on my discussion today. Okay? If you have some concerns, some clarifications, you email me at the Silliman University website. issue.edu.ph for your clarifications. But before you clarify, be sure you review this discussion. Review. Okay? Review. Then, the assignment I am going to give you will be based on what I discussed today. Okay? Just remember the different ways of expressing the direction in terms of geographical directions, east, north, west, south, or in terms of clockwise and counterclockwise. when you use clockwise or counterclockwise, when you use clockwise or counterclockwise angles, it should start always from the positive x-axis. From the positive x-axis. Or from the east coordinate. You start there. Okay? If you're a pilot, okay, as introduced in our chapter 3, the pilot is asking the information coming from the ground controller. Controller, please give me the vector. And the controller is giving the vector. The vector there, the angle and the distance from the tower, control tower of the airport is given. But the angle there is measured from the north. That is their usual measurement of the direction of the vector. In our case, we use these geographical coordinates. Our basis of the angle would either be from the west or from the north, from the south or from the east. Okay, here, vector is located, vector C located from east-south coordinates or from the east-south quadrant. This is a quadrant. There are 4 quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. The vector is located at the fourth quadrant. This is vector C. Located at the fourth quadrant or the east-south quadrant. Okay? Okay. You review this one, then after reviewing, you answer the assignment. If you do not understand, review. Still you do not understand, review. Still you do not understand. You email me, sir, what do you mean by that? What do you mean by this? You clarify after you have reviewed this discussion. Okay? Bye.